This is the second part of graphing inverse functions. We have here the function f of x is equal to 2x minus 1 all over 3x plus 4. Since this is a rational function, we have to get the vertical asymptote and the horizontal asymptote. If you forgot how to get the vertical asymptote, we will simply take our denominator and equate it to 0. So that's 3x plus 4 is equal to 0. Now, we have to transpose 4 on the right side in order for us to get our value of x, which is x equals negative 4 over 3. So we will place it here in the vertical asymptote. X equals negative 4 over 3. 4 divided by 3 is approximately 1.33. So our x here is negative 1.33. Next is our horizontal asymptote. To get our horizontal asymptote, we will only get the numerical coefficient of our numerator and our denominator, and that is 2/3. That is approximately 0.67. And we are now ready to graph. Let us first plot our asymptotes. Negative 1.33 in the x-axis is located here. So we'll just have to have a vertical line passing through that point. And then our horizontal asymptote is 0.67 in the y-axis. So it is in this point. So again, we'll just have to create a line passing through that point. Now remember that asymptote is a line or a curve wherein our graph approach to it but never touch it. Now let us decide for our x values. To do that, let us have the vertical asymptote as our basis, and we'll get two numbers from both sides. Let's start. To its right, we have the numbers 0 and 1. To its left, that is negative 2 and negative 3. Now, individually substitute our x values to our function. Let's start with negative 3. Negative 3 times 2, it's negative 6 minus 1, so that's negative 7. And then negative 3 times positive 3 is negative 9 plus 4, so it's negative 5. Dividing those two numbers, we have 1.4. Let us plot this point directly. We have here negative 3 and positive 1.4. So it's in this point. Next is let us substitute negative 2. Negative 2 times positive 2 is negative 4 minus 1. So it's negative 5. And then 3 times negative 2 is negative 6 plus 4. So it's negative 2. Now this is positive 2.5. Let us plot it. We have here negative 2 and then positive 2.5. We can create a curve here. Again, remember not to touch the asymptotes. Okay, so this is our first graph. Now let us continue with 0. What's left in the numerator is negative 1 and positive 4 in the denominator. This is negative 0.25. Plotting this point, we have here the point on the y-axis. It's this point. And then continuing with 1. 2 times 1 is 2 minus 1 is 1 over 3 times 1 is 3 plus 4. It's 7. This is equal to 0.14. Plotting that point, we have here 1, And then 0.14 is just a little above our axis. So this point. Now let us connect the dots using a curve that approaches the asymptotes but never touch them. So this is the graph of our function 2x minus 1 all over 3x plus 4. So how about the graph of its inverse? As usual, we will first get our vertical and horizontal asymptotes. Since this is an inverse function, we will simply interchange our asymptotes. Therefore, our vertical asymptote here is now 2/3 or approximately 0.67, while our horizontal asymptote is now negative 4/3, or again approximately negative 1.33. So we'll still use the same Cartesian plane so that we can see the reflection. We have here 0.67 in the x-axis. So we will simply create a line that touches that point. I am using a blue pen right now so that we won't be having confusions later on. Next, our horizontal asymptote is a line that touches negative 4/3 in the y-axis. So it's this line. Let us now proceed on our table of values. Remember that if it's the graph of the inverse, we will simply interchange our x and y values. So instead of negative 3, our x will now be 1.4 paired to negative 3. Locating that one in our Cartesian plane, we have here 1.4, negative 3. So it's in this point. And then, let us proceed to the second point, which is 2.5 paired with negative 2. So it's this point here. Now let us create the curve again, connecting the points. Remember not to touch the asymptotes. As you can see, this graph here is the reflection of our original function. So let us continue here to get the reflection of the other one. Negative 0.25 is paired with 0. So it's in this axis. Okay. And our last point here is 0.14 paired with 1. So locating that one in our Cartesian plane, we have here 0.14 going up to 1. So it's this point. Now let us create a curve connecting the 2 points. Remember not to touch the asymptotes. So it would be this curve. Now as you can see, this graph here is the reflection of this graph. So if you will place the reflection line, you'll see that they are reflections of each other. So we already have the graph of the inverse function here, but we don't know yet our inverse function. To do that, let us use our original given. So f of x is equal to 2x minus 1 all over 3x plus 4. Remember that f of x can be written as y. Now let us proceed with the steps on getting the inverse function. First is to interchange x and y. So our y here will become x. X equals, copy 2, and then that's y minus 1, and then 3y plus 4. The next step is to solve for y. Our new given looks complicated. However, remember that every whole number has a denominator of 1. In that way, we can now cross multiply. X multiplied to quantity 3y plus 4 is equal to 1 multiplied to quantity 2y minus 1. Let us distribute x in each of the term here. So that's 3xy plus 4x equals, this will result to 2y minus 1. Now we have to place all of the terms with the variable y on the left side. So from positive, it will become negative 2y equals, from positive, it will become negative 4x minus 1. Since y is common here, we will factor it out. So what's left is 3x minus 2. And then we will simply copy whatever is on the right side. Now to get the value of y here, we have to divide both sides by the entire quantity, 3x minus 2. Now canceling the common quantity here, our y is equal to the entire thing here, negative 4x minus 1 all over 3x minus 2. We will be placing this one here above. So our inverse function is negative 4x minus 1 all over 3x minus 2. There is actually another way of writing this one. That is by factoring out and canceling out the negative. So we have here to factor out negative. So what's left is 4x plus 1 all over negative of negative 3x plus 2. Now we will cancel out the negative. So another answer is positive 4x plus 1 all over negative 3x plus 2. That is all for today. Thank you and see you on our next video lesson.